Hi everyone and welcome to Dawson Tools. Today we're going to go ahead and take a look at our DAN100 and our DAN120, our analog multimeters. Let's take a look at the features on the DAN100. The DAN100 comes with a special set of test leads that only fit this meter, so only the provided test leads will work with this meter. Moving the rotary switch clockwise, the first 4 positions measure DC voltage. The voltage range of your circuit will determine what position you need to move the switch to. Once you've set the switch to the appropriate range, you're ready to measure DC voltage. The needle on the scale at the top of the meter will move from left to right to measure value. Depending on what range you put the meter in will determine which scale you use, so keep this in mind when reading the measured value. Continuing to move the rotary switch clockwise, the next 4 positions measures AC voltage. As with DC voltage, the position you need to move the switch to will depend on the range of the voltage to be measured. After the switch is in the correct position, you're all set to measure AC voltage. You can use the same method for reading the scale as you did with the DC voltage. Another measurement that can be made in any of the AC voltage range is transistor gain. Using the red scale at the bottom along with the chart in the bottom right area of the scale, you can measure the transistor gain in decibels. Moving clockwise again, the next 3 positions on the left side of the meter is DC current. As before, the position you need to put the switch in will be determined by what range you need. Once you've found the correct position, the meter is ready to measure DC current. For the 50 and 150 milliamp ranges, use 50 and 150 scales respectively, and for the 0.5 milliamp range, use the 50 scale and divide the reading by 100. The final position is resistance. Move the switch to the first position counterclockwise to off for resistance. Once you've done this, the meter is ready to measure the resistance of your circuit. The meter measures resistance in 1K increments. So using the green scale at the top, a reading of 1 on the scale means 1000 ohms of resistance. Now let's look at the DAN120. The DAN120 comes with and uses standard test leads, so unlike the DAN100, you can use any set of standard test leads with the meter. There are a few differences between the DAN100 and the DAN120. First are the larger set of ranges that can be measured by the meter. Second, the meter has 3 sets of ranges for measuring resistance as opposed to only 1 range on the DAN100. Lastly, the DAN120 adds 2 additional measurements that can be made with the meter. The first is the battery test. Depending on the type of battery to be tested, move the rotary switch to either the 1.5 volt or the 9 volt battery test position on the right side of the meter. When the meter is connected to the battery, the BAT scale on the bottom will indicate whether or not the tested battery is good or needs to be replaced. The second additional feature is the audible continuity test. Move the rotary switch to the continuity test position on the bottom right side of the switch. And when the meter is hooked up to the circuit, the meter will give off a buzzing sound if the circuit has good continuity. One final feature that applies to both analog meters is the calibration. There is an alignment knob that is just below the scale of the meter. You can use a flathead screwdriver to align the needle to 0 if the meter becomes misaligned. Also on both meters is a ohms adjust knob that you can rotate to calibrate any resistance-based measurement of the meter. And that concludes our demo for our DAN100 and our DAN120 analog multimeter. For more information, visit our website at www.dawsontools.com.